Now we start exercise 1.1. Question number 1. Differentiate the following with respect to x. So in previous lecture we see the proof of chain rule. So we have to apply here chain rule, because first we have to write given value as y. So we write here y equals to x cube minus 2x minus 1 raised to the power 5. So first we observe this is of the form y is equals to f of x bracket raised to the power n, because we know the standard form y is equals to x raised to the power n. Here in place of x, if there is function, that means here in place of x, function is x cube minus 2x minus 1, that is algebraic function. So we have to find the derivative of y equal to f of x raised to the power n as dy by dx is equals to n into f of x raised to the power n minus 1 into f dash of x. That means first we write the power in multiplication, we reduce the power of bracket, and then find the derivative of this bracket. So we write here differentiate with respect to x. This is short form. So we write differentiate with respect to x. Therefore derivative of y is dy by dx. So we write power in multiplication. So 5 into x cube minus 2x minus 1, and we reduce the power by 1. So we write here 4 into d by dx of this bracket. So x cube minus 2x minus 1. So we write here 5 into x cube minus 2x minus 1 raised to the power 4. Now here these three terms, so we have to these three terms differentiate separately. So we write derivative of first term, so d by dx of x cube minus, so 2 is constant, so we write 2 into d by dx of x minus d by dx of 1. So we write here 5 in bracket x cube minus 2x minus 1 raised to the power 4 into derivative of x cube. So we have to apply this rule, derivative of y dy by dx, derivative of x raised to the power n into x raised to the power n minus 1. So we write 3 in multiplication, we reduce the power of x by 1, so we write 3x square minus 2 into derivative of x with respect to x is 1 minus derivative of single constant is 0. So we write here 5 in bracket x cube minus 2x minus 1 raised to the power 4 bracket raised to the power 4 into 3x square minus 2. Now if you understand this, you can directly write the derivative of x cube as 3x square, derivative of minus 2x as 2, and derivative of 1 as 0. So for your better understanding, we write these two additional steps. You can write directly derivative of this bracket as 3x square minus 2. So in this way we solve first sub question. Now see second sub question. 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 bracket raised to the power 5 by 2. So this is again of the form y is equals to x raised to the power n. So here in place of x, this bracket, so this convert to y is equals to f of x bracket raised to the power n. So we have to write derivative of y as dy by dx is equal to n into f of x raised to the power n minus 1 into f dash of x. So first we denote this given part as y. So y is equals to 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 bracket raised to the power 5 by 2. So we apply this rule. So we write here differentiate with respect to x. So derivative of y with respect to x is dy by dx. Then we write this power in multiplication. So 5 by 2 in bracket 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 bracket raised to the power 5 by 2 minus 1. into d by dx of this bracket. So we write first 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5. So we write here this 5 by 2 as it is, 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 bracket raised to the power. Here we have to cross multiply this. So 5 minus 2 we get 3. So we write here raised to the power 3 by 2 into, now we have to find the derivative of each term. So we write here 2 into derivative of x raised to the power 3 by 2. So we write d by dx of x raised to the power 3 by 2 minus 3 into d by dx of x raised to the power 4 by 3, then minus d by dx of 5. So we find derivative of x raised to the power 3 by 2 by using the concept derivative of y equals to x raised to the power n. Here also we apply the same rule. Then derivative of constant we write 0. So we write here 5 by 2 in bracket 2x raised to the power 3 by 2 minus 3 into x raised to the power 4 by 3 minus 5 raised to the power 3 by 2. In bracket 2 is constant. So we write this power in multiplication. So 2 into 3 by 2 into, we have to reduce the power of x by 1. So x raised to the power 3 by 2 minus 1 minus 3 as it is, 3 into, so we write this power in multiplication 4 by 3 into x raised to the power 4 by 3 minus 1 minus derivative of 5, that is single constant. So we write its derivative as 0. So we write here 5 by 2 2x raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 raised to the power 3 by 2. So here these 2 get cancelled with this denominators 2. So 3 into x raised to the power 3 by 2 minus this 3 get cancelled. So write 4 into x raised to the power. So when we cross multiply this, we get here 3 by 2 minus 1, we write this power as, after cross multiplication 3 minus 2 we get 1, so we write x raised to the power 1 by 2. Here also after cross multiplication 4 minus 3 we get 1, so we write 1 by 3 minus 0, so we will not write the 0. So if you write this in the form of root, so you can write this x as square root of x, this x as cube root of x. So we write this as dy by dx is equals to 5 by 2 in bracket 2. This x raised to the power 3 by 2 can also written as x root x. So we write first here this x raised to the power 3 by 2, x raised to the power 3 by 2, we write x root x because x power is 1, root power is 1 by 2. If we add the power 1 plus 1 by 2, we get x raised to the power 3 by 2. So we write this x raised to the power 3 by 2 as x root x. So we write here this x raised to the power 3 by 2 as x root x. Then minus 3 into, so we write this as 3 x raised to the power 4 by 3 minus 5 raised to the power 3 by 2. So this we write as into 3 into square root of x because power is 1 by 2 minus 4 into power is 1 by 3, that is cube root of x. So you can write this second term at second position. So we write this as 5 by 2 into 3 root x minus 4 cube root of x into this bracket 2x root x, or you can put this x as 3 by 2 for your convenience or for your understanding. I write this step. You can write this x raised to the power 3 by 2 as x root x if we required to take the common. So we write this 2x raised to the power 3 by 2 as it is, minus 3x raised to the power 4 by 3 minus 5 raised to the power 3 by 2. So we don't have a need to write this in the form of x root x. So we write this bracket as it is. So if you have to take common, then that time you can write this x raised to the power 3 by 2 in the form of x root x. So here we don't have a need to take common, so we write this bracket as it is. So in this way we find the derivative of sub-question second. Now see third sub-question, square root of x square plus 4x minus 7. So first we see this is of the form y is equal to root x. So in place of x we consider here y is equal to root of f of x, because in place of x here is value x square minus 4x minus 7. That means we have to write the derivative of y equals to root of f of x, and we know that derivative of this y equals to root x is dy by dx is equals to 1 upon 2 root x. So derivative of y is equals to f of x, we write 1 upon 2 root of f of x into derivative of f of x is f dash of x. So in previous two lecture we discussed all these things. So we write this as in solution y is equals to in root x square plus 4x minus 7. So we differentiate with respect to x. We get derivative of y as dy by dx, derivative of this root as 1 upon 2 root. So we write here x square plus 4x minus 7, then into d by dx of f of x. In place of f of x bracket is here, so x square plus 4x minus 7. So we write this as 1 upon 2 root x square plus 4x minus 7 into, so derivative of first term, derivative of x square is twice x, derivative of 4x is 4, because 4 is constant, derivative of x is 1, so write 4 into 1 as 4, and derivative of this single constant 7 is 0. So you can take 2 common, so 2x plus 4 can be written as in numerator 2 in bracket x plus 2 upon 2 in root x square plus 4x minus 7. So this 2 get cancelled, so we write in answer as x plus 2 upon root x square plus 4x minus 7. So in this way you can solve sub question 3. Now see next sub question 4, root x square plus in root x square plus 1. So for while solving the derivative we try to put bracket first, because when we put bracket that will be convenient for differentiating the inner and outer function. So when we write here bracket, that means this root is outer function and this term is inner function. So first we calculate the derivative of outer function always. So first we write here y equals to root x, and we know that derivative of root x is 1 upon 2 root x, but here in place of x value is x square plus root x square plus 1. That means this is of the form y equals to root of f of x. So we write derivative of y as dy by dx, this root derivative as 1 upon 2 root into derivative of this f of x, that is f dash of x. So we use this concept. So we write in solution y is equals to root of x square plus root of x square plus 1. So first we find the derivative of this outer. So we write here differentiate with respect to x. Therefore derivative of y is dy by dx, derivative of this root is 1 upon 2 root. So keep the terms in bracket as it is, x square plus root x square plus 1 into d by dx of this term in this root. So we write d by dx of x square plus square root of x square plus 1. So we write this first term as it is, 2 times root x square plus root x square plus 1. Now here we have to write derivative of first term d by dx of x square plus derivative of second term, that is d by dx of root x square plus 1. So we write first term as it is, 2 in root x square plus root x square plus 1 into derivative of x square is twice x. Here again we have to apply the rule of composite function, that means we have to find derivative of this outer function, that is derivative of root. So we write 1 upon 2 root x square plus 1 into d by dx of the derivative of term inside the root, that is x square plus 1. So we write here 1 upon 2 root x square plus root x square plus 1 into this 2x as it is plus 1 upon 2 root x square plus 1 into derivative of x square is twice x, derivative of 1 is 0. So in next step we write here 1 upon 2 root x square plus in root x square plus 1 in bracket 2x plus 1 upon 2 into root x square plus 1 into 2x, because 2x plus 1, 2x plus 0 is 2x. So these 2 get cancelled. So we have to write here 1 upon 2 root x square plus root x square plus 1 2x plus, so we write here x into 1 as x, so x upon root x square plus 1. So in this way we calculate the derivative of this root of x square plus root of x square plus 1. Now see sub question 5th, 3 upon 5 into cube root of 2x square minus 7x minus 5 bracket raised to the power 5. So first we clear here concept nth root of x. So this nth root of x can be written as x raised to the power 1 by n. You know the example, square root of x. So here we write a square root, that means we have to take here 2. So we write here x raised to the power 1 by 2. Cube root of x, so we write x raised to the power 1 by 3. So we use this concept, this n has value 3 here. So we write this cube as power raised to the power 1 by 3. So we write this as, in solution, y is equal to, let y equals to 3 upon 5 into cube root of 2x square minus 7x minus 5 bracket raised to the power 5. So first we simplify it, then differentiate. So we write 3 upon 5 into, so we remove this cube root, so we write 2x square minus 7x minus 5 bracket raised to the power 5 and this cube we write raised to the power 1 by 3. So again we apply the rule, a raised to the power m bracket raised to the power n can be written as a raised to the power m into n. So we write this as 3 upon 5 in bracket 2x square minus 7x minus 5 bracket raised to the power 5 into 1 by 3. So here in place of m value is 5, in place of n value is 1 by 3. So we multiply the power of this bracket. So we write this as 3 upon 5 into 2x square minus 7x minus 5 raised to the power 5 by 3. That means we have to find the derivative of 3 upon 5 cube root of 2x square minus 7x minus 5 raised to the power bracket raised to the power 5. That means we have to find the derivative of this term y is equals to 3 upon 5 into in bracket 2x square minus 7x minus 5 bracket raised to the power 5 by 3. So we find the derivative of this last term. So for that we have to write this power, the terms in denominator, this power we reduce to negative form. So we again use here concept a raised to the power m can be written as 1 upon a raised to the power minus m, or a raised to the power 1 upon a raised to the power m can be written as in numerator a raised to the power minus m. So when we interchange we get the value. So we write this as, so we write 3 by 5 separately, and this 2x square minus 7x minus 5 raised to the power minus 5 by 3. So this denominator term we write in numerator. So we differentiate here, differentiate with respect to x. That means in some problem we have to simplify the given terms, then we have to differentiate that value. So here this 3 by 5 is constant, and this constant is with this function, algebraic function. So we write here, therefore dy by dx is equals to 3 by 5 as it is into, so here we apply the rule of x raised to the power n. So we write here power in multiplication, that is minus 5 by 3 into 2x square minus 7x minus 5 raised to the power minus 5 by 3 minus 1 into, again we have to find the derivative of this bracket, into d by dx of 2x square minus 7x minus 5. So we write this as this 3 by 5 into, so we simplify this first. So we write here this 5 get cancelled, 3 get cancelled, so minus in bracket 2x square minus 7x minus 5 raised to the power. So when we cross multiply this we get minus 5 minus 3, that is minus 8 by 3 into derivative of this bracket. So derivative 2 is constant, derivative of x square is twice x minus 7 into x. So 7 is constant, derivative of x is 1. So 7 into 1 we write 7, derivative of 5 that is constant is 0. So we write here square bracket. That means we find the derivative of each term. 2 is constant, so we have to find the derivative of x square. So we write derivative of x square as 2x. 7 is constant, so we have to find the derivative of x. So derivative of x is 1. So we write 7, or we can write 7 into 1. So write in next step. This power is negative, so we write that in denominator. So we write minus 1 upon 2x square minus 7x minus 5 raised to the power plus 8 by 3, and this we multiply 2 into 2, 4x minus 7. So you can write this as, so when we multiply by minus sign you can write this minus minus plus 7 and plus minus minus 4x, 2x square minus 7x minus 5 raised to the power 8 by 3. Or you can also write this as 7 minus 4x upon cube root of this 2x square minus 7x minus 5 raised to the power 8. Because this 1 by 3 we write as cube root, and this 8 as power of this bracket. Now see, last sub question of question 1. So we denote this as y equals to root of 3x minus 5 minus 1 upon root of 3x minus 5 bracket raised to the power 5. So we apply here y is equals to x raised to the power n form. So we write derivative of this. So we write differentiate with respect to x. So derivative of y is dy by dx. We write this power in multiplication. So 5 into root of 3x minus 5 minus 1 upon root of 3x minus 5 bracket raised to the power 5 minus 1, that is 4, into d by dx of this bracket. So we write 3x minus 5 minus 1 upon 3x minus 5. So we have to find the derivative of first term minus derivative of second term, but we have the rule for derivative of root x, that is 1 upon 2 root x, but we don't have the rule for 1 upon root x. So we have to reduce that power raised to the power 1 by 4, 1 by 2 form. So we write here 5 in bracket root 3x minus 5 minus 1 upon root 3x minus 5 bracket raised to the power 4 into, so first we separate the derivative, d by dx of this root 3x minus 5 minus d by dx of, so if we remove this root, so we write this as 3x minus 5 raised to the power minus 1 by 2. So we write this equals to 5 in bracket root 3x minus 5 minus 1 upon root 3x minus 5 raised to the power 4 bracket raised to the power 4. So we write here derivative of root is 1 upon 2 root. So we write 1 upon 2 root 3x minus 5 into derivative of this 3x minus 5. So derivative of, we write again here one step more, d by dx of 3x minus 5 into derivative of this, so minus, we write this power 1 by 2 in multiplication. So we get here minus minus plus 1 by 2, or you can write here one more step. So in bracket minus 1 by 2 3x minus 5 bracket raised to the power minus 1. So minus 1 by 2 minus 1. So we get here minus 3 by 2 into d by dx of this 3x minus 5. So you have to write here square bracket. So we write this first term as it is, that is 5 into root 3x minus 5 minus 1 upon root 3x minus 5 bracket raised to the power 4 into, so we write this 1 upon 2 root 3x minus 5. Now we directly write here derivative of 3x is 3, derivative of 5 is 0. So 3 minus 0 we write 3. So we write this 3 in numerator. So you can write this as 3 by 2 root 3x minus 5. Here minus minus get plus. So we write here plus 1 by 2, this power minus 3 by 2, if we write in denominator, we write 3x minus 5 raised to the power plus 3 by 2 into, so derivative of 3x minus 5, we write 3, so we write here 3. So in this way, we get 5 in bracket root 3x minus 5 minus 1 upon root 3x minus 5 bracket raised to the power 4. So you can take common 3 by 2, 3 by 2. So into 3 by 2 in bracket, we write here 1 upon in root 3x minus 5 plus we take 3 by 2 common. So this 3 by 2 can be written as 1 upon 3x minus 5 into root 3x minus 5. So this will be the required answer.